Good afternoon, Teacher Kathleen.
How are you this afternoon?
We are fine, thank you. How about you?
I'm also fine. So it's time for agriculture, and in our lesson today we are going to do soil. And under soil, we are going to do ability of soil to hold water. How many types of soil do you know? There are 3 types of soil. Good, Jesse. Which are these 3 types of soil you know? Yes, Jasmine?
Clay soil.
One is clay soil,
Sand soil.
and the last type of soil?
Loam soil.
Very good, loam soil. So the 3 types of soil that we have are clay, sand, and loam. Today I want us to look at how this soil, these 3 types of soil hold water. What do you see when it rains?
In sand soil, when you pour water, it doesn't stay there for long.
Yeah, when it rains, when you observe what happened on sand soil, the water will immediately dry up on sand soil. What about what happens on clay soil? Yes.
When the water pours on clay soil, it stays there for a long time.
Very good. Why do you think water dries up quickly on sand soil? What is the main reason why water dries quickly on sand soil? Let's hear the answer from Oshiri.
Because it has large particles.
Very good. The reason why water dries up quickly on sand soil is because sand soil has large particles. Why is it that water stays for some time on loam soil before it dries? Why? Because it has medium-sized particles. The particles are not too large like the ones for sand. What about clay? Why is it that water stays there for a very long time before it dries? Why is it that water stays on clay soil for a very long time before it dries up?
Because it has small particles.
Because clay soil has small particles. Because clay soil has small particles. In case of loam soil, the particles of that type of soil, they are not too large like the ones for sand and not too tiny like the ones for clay. That's why we say the size of particles of loam soil is medium size. Are we together?
Yes.
So today I want us to carry an experiment or an activity whereby we are going to determine which soil holds water for a long time and which soil does not hold water for a long time. With me here are the things that we are going to need for the experiment. First, we have these 3 containers, and then we've got some water. After measuring sand, clay, and loam, we are going to put them in these 3 containers here. One is labeled sand, the other one is labeled
Loam.
and the other one is labeled what?
Clay.
So after measuring the soil, we are going to put it in the 3 containers, and then we are going to measure water in the same containers. The same amount of water and the same amount of soil, so that we can be able to determine which soil holds water for a long time and which soil holds water for the shortest time. After measuring sand, clay, and loam, we are going to put them in these 3 containers here. One is labeled sand, the other one is labeled
Loam.
and the other one is labeled what?
Clay.
So after measuring the soil, we are going to put it in the 3 containers, and then we are going to measure water in the same containers. The same amount of water and the same amount of soil, so that we can be able to determine which soil holds water for a long time and which soil holds water for the shortest time. Are we together? I also have loam soil here. This is loam. And I also have sand soil. Both of them are sand soil. And then I have some clay soil in this paper bag. So first, our first step is to block this part with cotton wool. Why do you think we're doing this? What is the reason for doing this? The first step is to block this part with cotton wool. Why are we doing that?
To block the soil from the
Yes, to prevent the soil from pouring out. Shortest time. Which soil holds water for the shortest time? Yes.
sand soil.
Sand soil. Very good. Which soil holds water for the longest time? Aiden?
Clay soil.
Clay soil.